Bismillahir Rahmanir Rahim. Assalamu alaikum wa rahmatullahi wa barakatuh. In the previous discussion, we completed chapter 10 of our book, and that was regarding one sample tests of hypothesis. And today we are going to start chapter 11 of our book, and this is two sample tests of hypothesis. So basically, the idea is that till now, if you recall your memory in chapter 10, we were only taking one population in our consideration. And we were saying that uh, based on our past experience, the population mean is this particular value. So we were confirming that value using some sample data. But what will be the situation if we take two different populations into our account, and we say that whether the average averages of two different populations are equal or not. So when two populations are there into our account, then we use two sample tests of hypothesis. So basically, initially, if you see, we were taking into our account one population, and we were saying that that population is normal. And on this axis, we were taking x bar. That was the distribution of sample means. Okay, because we were taking different samples, and there were different samples, and then definitely sample means. So then there was mean of sample means in the center. That was, we were saying that that was equal to mu is equal to x bar, or you say basically saying this mu is equal to mu x bar. So then we were standardizing the curve, and we were taking z, or in some cases we took t scale, where population standard deviation was unknown, and when it was known we were using z. But now, as there are two populations in our consideration, we may again take help of central limit theorem. We may say that now this scale may be x bar minus x bar. So you may write it down as x1, x2. So basically now, as two populations are in our consideration, and we are saying that as in case of one population, the distribution of sample means was normal, or you can say approximately normal. Similarly, if we take differences between the two sample means, and we generate a data series, that is the series for differences of the sample means. So definitely there will be a series, if you see in your book like this. Let's say this is the example. Samples are there, 20 samples are there, plumbers and electricians. So difference, so what is this difference? What is this value 29.80? Basically, there was 40 values in the sample, and we added 40 values and then divided with 40, and then we obtained this value. So this is the sample mean for first sample. This is the sample mean for second sample, third sample, fourth sample. So these are the means. So distribution of these means will be normal. So this was the case that we were taking in chapter 10. But let's say there are electricians also there, and we want to compare plumbers and electricians. So then definitely the let's say these are the incomes or earnings. So these are the earnings of the electricians. So definitely the sample of 40 electricians was there. We took sample of size 40 for electricians, and we found this value as average or mean. So simply we added the 40 values divided by 40. Why I'm talking about 40? Because 40 is there. In case of plumbers, let's say better would be if we read this example, then the idea will be further clarified. So this was some example, shows the result of selecting 20 different samples of 40 plumbers and 35 electricians. So basically 35 electricians are there. So this value 28.76 could be find out if you add those 35 earnings and divide by 35. So this will be the answer. And similarly in this case you obtained different values for the plumbers earning, and definitely those were 40. So add all those earnings, divide by 40. So this is the answer. So similarly, take another sample, another sample. So in total, you may take 20 samples, each comprised of size 40 in case of plumbers, and each contains 35 values in case of electricians. So we are saying that if we take the separate series, then the plumber series will give you the normal distribution. I mean x bar. This will be the situation. This situation x bar will be there on this scale, and if you take the difference, the series of differences, then you draw this series on the in form of a graph distribution, this distribution. So this distribution again will be normal. So central limit theorem will again work in this case. So here again, if the population standard deviation is known, you will use z distribution, and if it is unknown, then you will use t distribution. So in the center there is mu x1 bar, mu x2 bar, as it was in this case it was equal to, you may also say that this is equal to mu, and as in this case mu was equal to this. So when there are two populations, so this will equal this. We can also mathematically prove this, but that is not our scope in this course, so we are not going to prove this. But this is equal to this, and we basically, when we were on campus, we had proved this, so we can also prove this using the same strategy. So definitely, if population standard deviation is known, so this will be the z scale that we will take into our account. And if populations basically, as two populations are there, so populations standard deviations are unknown, then we will use t distribution. T scale basically will be there in that case. So central limit theorem works, and if you see the formula, z formula in this particular case, that you will use as z statistic, this will equal x1 bar minus minus x2 bar and minus mu1 minus mu2 divided by sigma 1 square divided by n1 plus sigma 2 square divided by n2, and there is square root on these two terms. So basically, if you write down this formula in concise form, basically the formula was like this: z is equal to mu x1 bar mu x2 bar minus mu divided by, so definitely in this case, as two populations are there, so mu1 minus mu2, this was the situation, and divided by again sigma 1 square, or or you can simply say sigma square x1 bar minus x2 bar. So basically this was the formula. If you recall your memory, we had proved previously when one population was in our account, we wrote the formula in this form: mu x bar minus mu divided by sigma x bar, like this. Definitely, there is square root on this. No, sorry, square root is not there. This was the value. Basically, we are saying that sigma x bar was equal to sigma, and we had proved this sigma divided by square root n when we were on campus. So similarly, if you take into your account sigma square over here, then square root will be here, right? And if you are going to take sigma square over here, square root will be here. Okay, because we know sigma square, if you are going to take sigma square, what will be the situation? There will be square on this, so this will equal sigma square divided by n. Okay, so we are basically taking square root in the denominator. So these are different formulae. Basically the formula is same that we initially used for z. So we have derived all these formulae from that basic formula. So basically simply shapes are different, but the concept is same. So now in this case, we are going to use this formula, and we know that this is equal to, in this case, sigma x1 bar minus x2 bar square. This is equal to, I have already copied it over here. If you see this, sigma square x1 bar minus x2 bar is equal to sigma 1 square divided by n1 plus sigma 2 square divided by n2. So there is a square root on this in the formula, if you see this. And what about this mu1 minus mu2 that I have written over here? Basically, we are saying that mu1 is equal to mu2. So if mu1 is equal to mu2, let's say mu1, so if you are going to construct the null hypothesis, so mu1 is equal to mu2, and you are going to say that there is no difference between means, that will mean that the mu1 minus mu2 is equal to 0. So if you write it down as mu1 is equal to mu2, so you may write it down in this way: mu1 minus mu2 will equal to 0. So in all cases, when mu1 is equal to mu2, this term will become 0. This term will become 0. So therefore, in your book, if you see, the formula is only up to x1 bar minus x2 bar, and there is no explanation, or you can say there is no information regarding mu1 minus mu2. So because mu1 minus mu2 is there, but that is equal to 0. So there is no need of writing that over here. Okay, so now we will use this formula, this z statistic, when there are two populations in consideration, and this formula will help in finding out this term. Sigma 1 square means that the standard deviation for first population, standard deviation for second population, these two are known, and we are interested in finding out the z value, z statistic in that case. So let us solve one example from your book that will further clarify the idea. This example you may solve on your own because it is completely solved over here. You may take help of this example completely solved in your book. I can simply explain this if you are interested. Then we shall solve the self-review. So let us consider this example. Customers at the Food Town supermarket have a choice when paying for their groceries. They may check out and pay using the standard cashier assisted checkout, or they may use the new fast lane procedure. In the standard procedure, a food town employee scans each item and puts it on a short conveyor, where another employee puts it in the bag and then into the grocery cart. In the fast lane procedure, the customer scans each item, bags it, and places the bags in the cart, him or herself. So you normally observe this in big metro malls, shopping malls. The fast lane procedure is designed to reduce the time a customer spends in the checkout line. The fast lane facility was recently installed at the Birni Road Food Town location. The store manager would like to know if the mean checkout time using the standard checkout method is longer than using the fast lane. She gathered the following sample information. The time is measured from when the customer enters the line until all his or her bags are in the cart. Hence, the time includes both waiting in line and checking out. What is the p-value? So this is the situation, and if you see this in tabulated form, required values are provided. Customer type who are using the standard method, they are we have taken 50 of those customers who used the standard conveyor method, and we found the mean as this, and the population standard deviation was known already from past experience. So this was 0.40 minute. And using fast lane, these 100 used fast lane, and we took their sample, and we found that on average 5.3 minutes were used by a typical user who used fast lane. And this is the population standard deviation that we know from our experience. So all these values are given, and we can find out the z value. So how will you set the null and alternate hypothesis? If you see, this S is for standard and this F is for fast lane. So standard lane, you may say standard lane and fast lane. So how will you construct this? First of all, again, in case of, as we have already done in chapter 10, that we construct alternate hypothesis first and then we write down the null hypothesis. So in this particular case, the sentence that is written over here will help you. This word longer is helping you. So again, write this sentence. The store manager would like to know if the mean checkout time using the standard checkout method is longer. Standard checkout method is longer. So it means mu S is greater than, using the fast lane means mu F. So mu S is greater than mu F. Mu S is greater than mu F. So you will construct this alternate hypothesis, and once you will be able to construct the alternate hypothesis, the null hypothesis will automatically be constructed. So the remaining two possibilities will be written over here, less than or equal to. Then level of significance, it is also given. If you see in the question, I think it is given. Let's say it is not given, but it has been provided over here. We normally use 5% level of significance. So, but in this case, he has selected 0.01 significance level, as it is not given in the question. So you may use 5%. Okay, but as your book is using 1% over here, so we may find out the results using the given 0.01 level of significance. Then determine the test statistic, or you can simply write down test statistic, and that is the same test statistic that I have written over here. This is the test statistic. Then comes formulate a decision rule. So decision rule will be devised. If you see, the method is same that we have already done in case of one population. So this is Z scale, and in this particular case, this is X1 minus X2. So basically in this case, this will become SXS and XF, this scale. So if you see in your book, this scale is not given. He is simply using the Z scale. So it's upon you. You can simply use z scale, or you may also give this scale to the distribution. So in the center, the values are equal. I mean, mu s is equal to mu f. Mu s is equal to mu f. This is in the center. Fine. And definitely against this, the value of z will be 0. Okay. So now you have to decide that whether this is right-tailed or left-tailed, because this is single tail. So this kink is helping you that you must put the tail to the right side of the distribution, or upper. It is an upper tail. Upper tail means right tail. So this is the right tail. And as you are using zero point 0.01 level of significance, so you may say that this is equal to 0.01. So basically, you are interested in finding out the critical value. What will be the critical value? Definitely, the bounded area will give you the value for z, and that is definitely 0.5 minus 0.01. And what will be the answer in this particular case? If you subtract it, 0.4900.
49. Yes.
0.
Yes, sir. Point four nine.
0.4900. So what will you do? You will locate this value here in the table. This is your z table, and 0.4900 we have to locate in body of the table. So if it is not there, we will consider the nearest value. So as it is not there, but this value is the nearest value, 0.4901. This is nearer as compared to this value, to the 0.4900. So consider this value, and then move leftward 2.3, and then from this point move upward and see this is 3. So this plus this 2.3 plus 0.03, the answer is 2.33. So 2.33 is your critical value, 2.33. Okay, so this is the step 4 of your procedure, and here you will write down that in which situation you will be rejecting the null hypothesis. So let me write down that statement over here. Basically, I want to move this cursor down. I don't know why it's joking with me. It's joking with me. Okay, let me write down this statement over here, but you have to write down the statement down the graph. So you will write down over here if this is the tabulated value. This is the z tabulated value. So you will write down over here if calculated value of z statistic will exceed the tabulated value of z statistic, we would reject H naught. Why this will be the situation? Because if calculated value of z will exceed this particular value, that will be somewhere to the right side of this value. I mean, that will be in this region, and this is the rejection region. This all is the exception region, or this is the region where we will remain unable to disprove the null hypothesis, and this is the region where we will reject the null hypothesis. So this is the rejection region. So any value more than 2.33 will be in the rejection region. So in that particular case, we will reject H naught, and if some value, calculated value, will be less than this value, we will be in this region. That means we would accept the null hypothesis, or otherwise, in other words, you can say if some value is less than 2.33, the critical value, we would remain unable to reject the null hypothesis. So you will write down this in step 4, right? You may see this graph also. Then comes the calculation or computations step, that is step 5. So you may simply substitute the values given in the question over here in the formula in this step. So like this, 5.5 minus 5.3, these values are given in the question. 5.5, 5.3. So for standard it was 5.5, for fast it was 5.3. So you will substitute the values, and similarly standard deviations are also given. So you will substitute all these values, and you will find out the result, that is 3.123. So you can simply see that this is greater than 2.33. So you will say that as the calculated value has exceeded the tabulated value, so we would reject H naught. So you may see over here, our decision is to reject the null hypothesis and accept the alternate hypothesis. So you are going to accept the alternate hypothesis, and that was this. This is the alternate hypothesis that you will accept in this particular case. So what that means, you will explain this meaning in the step 6. So you may say in this particular case, if you see, this is regarding time, minutes are there. So if you see, you are going to accept this. So mu s means on average standard method is taking more time as compared to the fast lane. So you may say that fast lane is better because that is taking less time when regularly customer enters in the lane and until it puts all its luggage in the cart. So as mu f is less, it means less time is being consumed in fast lane as compared to standard lane. So your decision or conclusion will be that fast lane is better. Lane is better. She gathered the following sum. So this is the information. Hence, the time includes both waiting lane. So this all information was given, but you are going to answer this question. Would like to know if mean checkout time using the standard checkout method is longer than using the fast lane. So you will say yes, it is longer. Standard checkout method taking more time as compared to fast lane. So fast lane is better because less time is being consumed in the fast lane. Right? So whatever you have seen in sample, that is not by chance. Actually, that is being occurred. So in this way, you are taking into your account two populations and you are solving the question. So now we may solve this question completely. Let us try solving this question. Tom Savitz is the owner of the appliance patch. Recently, Tom observed a difference in the dollar value of sales between men and women he employs as sales associates. So he employs as sales associates men and women. Okay. So he wanna observe the difference in dollar value of sales that basically men and women are selling. A sample of 40 days revealed the men sold a mean of $1,400 worth of appliances per day. For a sample of 50 days, the woman sold a mean of $1,500 worth of appliances per day. Assume the population standard deviation for men is $200 and for women it is $250. At the 0.05 significance level, can Mr. Savitz conclude that the mean amount sold per day is larger for the woman? Okay, so again, the word larger is there, and this will help us in constructing the alternate hypothesis. And you may see that definitely there are two populations. One population is for men and the other for women. So there are two populations. Averages are there. I mean, sample average, sample mean in case of men, and also for women. So standard deviations for populations are known. So you will use the z distribution. So this all you may conclude by just reading the story. So now let us answer all parts one by one. State the null hypothesis and the alternate hypothesis. So how will you write it down? You will write down step one, or you, in this particular case, as steps are not involved, so you have to answer all parts. So first part, what is required? State the null and the alternate hypothesis. So you will write down over here null hypothesis and H1 for alternate hypothesis. So as I have said, you will construct the alternate hypothesis first. So averages are involved, so you will write down mu. Here you will write down mu and mu. So now you have to give the subscripts. So for your convenience, you may give subscripts as W and M. So M will represent men and W will represent women. So let us write down over here men and here women. So same you write down over here M and W. And then you have to decide that which one is larger. So if you have for that you have to see this statement. Can Mr. Savitz conclude that the mean amount sold per day is larger for women? Is larger for women means the sign will be like this. Larger for women. So if you are going to write down this, then the remaining two possibilities will be written in the null hypothesis. So you may construct it in this way. Otherwise, if you see, you may also construct it in this way. Step one, null and alternate hypothesis. This is step one. Again, I'm going to write down H naught, H1, mu, 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 and mu. And now, as I've written M over here, if I write down W over here, see what will be the situation. W, 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 and W. So now, sorry, no, not here should be, it should be M, W, and mu, 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 and here now I'm going to write down W, 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 M, M. So now how will you construct the alternate hypothesis? Can Mr. Savitz conclude that mean amount sold per day is larger for women? Larger for women in this case would be like this, larger. And the remaining two possibilities will be written in the null hypothesis. So you may construct the null and alternate hypothesis as this or as this. So what will be the difference if you are going to construct as this? So left tail will be there in the distribution, and in this case right tail will be there in the distribution. But remember that there will be no difference in conclusion. The conclusion will remain same. The interpretation in chapter 6 will in step 6 will remain same. There will be no difference in result. So you may construct the null and alternate hypothesis in this way or in this way, because these are same. If you see this, mu W is greater, and if you see this, mu W is also greater. But the king is to the right side in this case, So the tail in the distribution will be the upper tail, and in this case, the tail will be lower tail will be there in the distribution in this particular case, but results will remain same if you are going to use any strategy out of these two. So which strategy should I use in making the decision rule? It's upon you. Yes, the first strategy or the second strategy?
Well,
First one, sir.
second.
First one.
Second strategy. Okay, okay, fine. So what is the decision rule? What is the decision rule? So write down here part B. Answering part B, you will write down decision rule, and for that you have to draw the distribution. So here again you may write down this axis as x1 bar, x2 bar, or you can simply write down z scale. So it's upon you that for your convenience what are you going to write down. So in this case, as you're using this w minus mu w minus mu m. So here you can write down xw minus xm. This will be the scale, and here it will be z scale. Why? Because standard deviations are known. So in the center, if you write down, this will be mu w equal to m and in the center the z value will be 0. So now you will see that to which side there will be tail. So this kink is to the right side, so this is helping you to put the upper tail or right tail. So you will draw this tail, and against this you are interested to find out the value of z. So now you have to see, this is one tail, so see the level of significance. So level of significance is given, it is 0.05, 5%. So you have to write down alpha is equal to 0.05, write down this. And what will be the value over here for this part, this share? This will be 0.5 minus 0.05. So I think it will be 0.4500. Is it? If you have
Yes,
calculated,
sir.
you can find it out.
Yes, sir. The
0.4500.
value.
Yes, sir.
If this is the value, then see this value in the body of the table, 0.4500. This value is not there, but this value is in between these two. So you may take the above side value and you can find out the value of z. So 1.6 plus 0.05. So
1.65.
1.65 is the value. That is the critical value or the tabulated value. So 1.65 you will write down over here. So now here you will write down if the z calculated or z you can write down the z calculated value, or if the value for z statistic is the calculated value of z statistic will exceed the critical value or the tabulated value of z statistic, that is 1.65, we shall reject the null hypothesis. Otherwise, if it is less than 1.65, we shall accept the null hypothesis. So you will write down the decision rule in these two sentences or in one sentence. Then what is the value for t statistic? What is the value for t statistic? What is the value for the test statistic? What is the value of the test statistic? So test statistics value you can find out using z. So this is part C. So you will use the formula, that is x. In this case, definitely as you are taking w minus x bar, so you will write down that over here. xw minus xm. And as I've said that mu w minus mu m will be equal to 0. So there is no need of writing that down. Then sigma w square over nw will be there, because nw will represent the sample size of the woman. So here you will write down mu m square divided by nm. So definitely nm will be the sample size for uh, men. Okay, and then there is square root on these two terms like this. So now you can substitute all the values that are there in the question. So see what are the values and substitute the values and have the answer. So what is x sub w bar? X sub w bar is
40.
w. So this is for men. 1500. 1500 and 50 days, 1400 and 40 days for men. So write down 1500 minus 1500 minus 1400, sorry, 1400 divided by sigma w square. So what was sigma w square?
250, sir.
250.
So
This is the standard deviation. So 250 square you will write down over here. 250 square of 250. 250 square divided by nw. So n was 50
Yes, sir.
plus standard deviation for men 200 square divided by 40 and square root. So if you have calculator with you, you may solve it. See the answer.
2
This is
point 2.1081.
2.1081. You can confirm it from the answers because answers for self-reuse are there in the book. I don't know, but you have to check. Then there comes step part D. What is your decision regarding the null hypothesis? So here you see this is 1.65 and this is 2.10. So 2.10 is greater than 1.65. So what will you say? You will say that as the calculated value has exceeded the tabulated value or the critical value, so therefore we would reject H naught. We would reject H naught. Rejection of this means exception of this. Rejection of null means exception of alternate hypothesis. So what this means, mu W is greater. Mu W is greater than mu M. So interpret the result. Answering part F, you will write down. Uh, yes, Mr. Savage may conclude that the mean amount sold per day is larger for the woman. Yes, he may conclude this point. So definitely, if women are selling more than the men, it means definitely they are more efficient. Fine. And what is the p value? So answering part E, you will find out p value. And how will you find out p value? Simply you will take into your account this value 2.108. So you may take it as 2.11. 2.11. So now come in to the table and see what is the probability against this value. 2.1 is this, and move rightward until you are here 2.11. So 0.4826, 0.4826, 0.4826, 0.4826. Okay, and you have to subtract this value from 0.5 to have the p value. So p value will equal this. P value will be equal to this. So what is the answer for this? What is p value?
0.0174.
0174. 0174. And now as this is the required value, p value, so you may stop over here. But if you are using this value to decide about the null and alternate hypothesis, so then you may use this value, and you may use the strategy that I have already given you. P value, if less than alpha, then we would reject, but you have to see that what is the situation over here. So p value is 0.0174 and alpha was 0.0505. So which one is greater? Alpha is greater. Alpha is greater. So what will you say in this case? As probability value is less than alpha's level of significance, then we would reject H naught. Reject H naught. So you may also use this strategy to decide about null hypothesis. But it is not required over here, because here he's only interested in knowing the p value. So p value is this. So you may stop this step over here, right? So this was self-review 11-1. Then these are the exercises, and we may solve any example, any one at least now. So out of these 6 questions, any question you may ask me, and I may solve right now because we have few minutes.
सर क्वेश्चन 5 करो.
Question number 5. Okay. The question is, do married and unmarried women spend the same amount of time per week using Facebook? Same amount of time, right? A random sample of 45 married women who use Facebook spent an average of 3 hours per week on this social media website. A random sample of 39 unmarried women who regularly use Facebook spent an average of 3.4 hours per week. Assume that the weekly Facebook time for married women has a population standard deviation of 1.2 hours, and the population standard deviation for unmarried regular Facebook users is 1.1 hours per week. Use 0.05 significance level. Do married and unmarried women differ in the amount of time per week spent on Facebook? Find p value and interpret the result. So in this particular case, first of all, better would be if you write down the first of all, before starting step 1, write down over here values like this. Given information. What is given information? The given information is a random sample of 45 married women. Married women, 45. So as it is sample, so n will be there. As they are married women, so you may write down over here m, married women. Fine. And how many are they? They are 45. Okay. Then read onward. Use a random sample of 45 married women who use Facebook spent an average of 3 hours. Spent an average. Average of 3 hours means x
Mu.
m bar, because it is from sample, so not mu, it is x m bar, so it is 3 hours. Fine. Read onward. A random sample of 39 unmarried women, so n I am writing U, NU. So better would be if I use subscript as U, capital. Unmarried women, how many are they? 39.
20.
Okay. Then the spent an average of 3.4 hours. So in this case, XU bar will be 3.4 hours. Fine. What else is there? Assume that the weekly Facebook time for married women has a population stand. So they see population standard deviation is given 1.2 hours for married women, 1.2 hours. So here you can write down uh, sigma m. What is this? 1.2.
2.
And sigma u is equal to 1.1. 1.1. Fine. Well, what else is there? Significance level 0.05. This we may write down this in step 2. So let us write down step 1. So now everything is clear because standard deviations are there, so you will use Z statistic. Two populations are there, so you will construct the null and alternate hypothesis in which you will use mu. Okay. So null and alternate hypothesis, you will give this heading to this step, and then you will write down H naught and H1. So first of all, you will write down H1. Here you will write down mu, 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 and mu. So now you have to read the final statement that will help you in constructing the alternate hypothesis. Do married and unmarried women differ? So the word differ is there. The word differ is there. It means that we are not interested in knowing that whether the married women are spending more time on using Facebook, or unmarried women are using more time for uh, more time on Facebook. So we are not interested in that. Basically, we just want to know that whether the times differ or not. So for that, as this differ word is there, we are not interested in using more or less time. We are simply interested in knowing the difference in the times. So you will use inequality sign in the alternate hypothesis and equality sign in the null hypothesis. And here you will give the subscripts for your convenience. You may write down any, you may write down m, you may write down u, because this is the hypothesis where equality sign is there, so it will not matter. M and u, m and u. So null and alternate hypothesis are now there. Then step 2, alpha, and alpha will be 0.05 as it is given. Then step 3. In step 3, you will simply write down the formula, and definitely you will use Z statistic. So x minus x bar bar. Here m u divided by sigma divided by n, sigma divided by n. Square is there, square is there. This is m, this is m, u, u, plus is there, and square root is there. So this is the formula. So you will stop over here, and then you will move to step 4. So let me move to the next page. Okay, so here you will write down step 4. that is decision rule. So now you have to see that how would I draw the distribution and how I will decide about the. So here again, definitely this is x m minus xu, or u. There's no need of giving this scale because it is understood that this will be the value. It's upon you. This is the scale. Fine. Here the value is 0. Here the value is mu m is equal to mu u. Fine. And now please be attentive. Uh, Equality sign is there. It means the distribution is two-tailed. The distribution is two-tailed. So you will draw one tail to the left side, one tail to the right side. So upper and lower tails will be there. Fine. Now, what is level of significance? Level of significance is 0.05 or 5%. So you will divide that 0.5 with 2 because there are two tails. So alpha divided by 2. Alpha divided by 2 here and alpha divided by 2 over here. So this will become 0.05 divided by 2. The answer is 0.025. Right? And here again 0.05 divided by 2. The answer is 0.025. Right. So now take this value into your account and subtract this value from 0.5. So when you will subtract this value from 0.5, you will have the share of this area. So what is this area?
0.475, sir.
0.4750. So locate now this value. Definitely this side again will be
75.
0.4750. Both sides will be 0.4750. So you may also write it down over here, 50. So what is the z value against this value from table? 0.4750. This is the value. So against this 1.96 is the z value. 1.96, 1.96. So 1.96, 1.96 you will write down over here, and minus 1.96 you will write down over here. Okay. So now you will give the statement that if, I may write down that statement over here, no problem. There is some issue with this cursor. Yes, now it will come down. Okay. So you will write down over here if, make it further bold. Okay, 14. Is it visible? Is it visible?
Yes, sir.
Yes, sir.
Yes, sir.
If the calculated value of the statistic will be more than 1.96, or it will be less than minus 1.96, comma, we would reject H naught. So rejection regions are basically in two tails, in two tail distribution, or to two sides. So two rejection regions are there basically in this situation. So if value exceeds this value, you will be here, reject H naught. If the value is less than this value, you will be in this region, reject H naught. And from this particular point, I mean from 1.96 up to plus minus from minus 1.96 up to positive 1.96, the central region, this region is the exception region. This region is the exception region. So if z calculated is in between these two values, then you will say that uh, will we have remained unable to reject the null hypothesis. Okay, so this is step 4, and then you will move to step 5. And what will you write down in step 5? Computations. So computations, how will you compute values? Z calculated will be there. X, the values for x1 and x2 we have already written over here for our ease. So m minus w, so you may write down 3 minus 3.4, 3 minus 3.4 divided by 1.2 square, 1.2 square divided by, what was the sample size for this?
45.
45.
45. So write down 45 plus, what is the next standard deviation?
11.
1.1
1.1 square,
here. Fine, thank you. Divided by
39.
39 sample
39.
size, and then square root of this. Fine. So if you have calculator, please find it out. The answer will be with negative sign.
Minus 1.593.
593.
Yes, sir.
Okay, so you may take into your account 1.59. 1.59. So 1.59, this is the calculated value, minus 1.59. So write it down over here, 1.59. And what was the critical value? 1.96 minus 1.96. Okay, so which value is larger out of these two? This is
Minus
Z,
1.5.
this is Z tabulated. So with negative signs, these are the values. So which one is larger?
Z calculated, sir.
Z
Z
calculated is
calculated is
more.
larger. Okay. So this is the situation. So as larger means this value, you may say that 1.59 has exceeded this value, is more than this value. So we were saying that if it is less than this value, minus 1.96, then we would reject. But in this particular case, it is more than this value. 1.59 with negative sign is more than this value. So it means that you are here. This value will be somewhere here. 1.59, 1.59. Yes,
Yes, sir.
1.59. So 1.59 will be to this side. 1.59 with negative sign. Okay, so as values are going to getting near to 0, so they are becoming larger. So minus infinity will be to the left side. Let's say minus 10 is there, so minus 10 will be less than minus 1.96 because that will be to the left side. So this negative sign is basically the thing that you have to consider before deciding that which value out of these two is larger. So this is the larger value as it is near to zero. So 0 is the largest value if you move from minus infinity up to 0. And then normally values start increasing to the right side. So plus infinity will be the largest value if you move from 0 up to positive infinity. So in this particular case, you will write down, we have remained unable to reject the null hypothesis. So that statement you will give over here. As the calculated value is in the region, where we will remain unable to disprove the null hypothesis, therefore we would reject the we would not reject. We would not reject the null hypothesis. So you may give any statement like this in this step. And finally, you have to interpret the result in step 6. So exception of, so what this means, we have remained unable to disprove the null hypothesis means we have accepted the null hypothesis. So what is null hypothesis? The null hypothesis is this. So we have accepted this and what this means. So now you have to give what this means. This means that do married and unmarried women differ in amount of time as per week spent on Facebook? So you will say no. There is no difference of time that is being used by married and unmarried women using Facebook. So whether they are married or they are unmarried, they are spending same time on Facebook. Understand? So you write down this statement in step 6. Okay, you write down this statement. If you are interested, I can write it down. Should I write it down, or you can write?
Yes, sir.
Yes, sir, we can.
You can write down. Fine now.
Yes,
Fine.
sir.
You can fine. So very good. And then find the p-value and interpret the result. So now this is important. How will you find out p-value? So for this, you will consider straightforwardly two things may be there. There may be two strategies. One strategy is this, that as you have divided alpha by 2, okay, so as there were two tails, so you have divided alpha by 2, so now the new level of significance is 0.025 to right side, and 0.025, this is the level of significance to the left side. Fine. So you may consider this value and you may compare this value with the probability value. So let us consider the probability value using one side, and then we will use two sides. Okay. So what will be the probability if you consider one tail? So for that, you will consider the calculated value, that is minus 1.59, minus 1.59. So minus 1.59 will be to this side. Okay. And definitely if you are taking mu u minus mu m, then it will be positive value. So basically 1.59 is with negative sign, and it is also with positive sign. When it will be positive? When you will write down this 3.42 this side and 3 to this side. I mean, when you will subtract 3 from 3.4, the answer will become positive. So basically, this value is negative because you are writing the smaller value before the larger value. You are subtracting the larger value from the smaller value. So therefore, we have this negative sign with this value. But if you are doing it oppositely, then this will become positive. So basically, this value is with negative sign and as well as with positive sign. So when it is with negative sign, it is over here at this point, and when it will be with positive sign, so it will be at, let's say, at this point. So at this point, it is 1.59, but with positive sign. So in both cases, you would be in the exception region. You would accept the null hypothesis. So that doesn't matter that which value you are going to subtract from which value. In this particular case, when equality sign is there in the null hypothesis. Otherwise, if it was single tail test, then it does matter that which side you are going to use. So now we are interested in p-value, and for p-value, we are going to use this 1.59. 1.59. So see what is the value against this 1.59. 1.59. 0.4441. 0.4441. So you will write down this over here. 0.4441. You write down this value and you are interested in finding out p value. So p value is equal to zero point 0.5 minus this value. 0.5 minus this value. So what is the answer?
Point 559.
0.5
59.
0.559. So this is the probability value. What is this? This is the probability value. And then you have to compare this with alpha. And alpha in this case is basically alpha by 2. Alpha by 2. So we are, although we are not writing down alpha by 2, we are going to consider it alpha, let's say. But alpha in this case was this value, 0.025. So you have to compare this value with 0.025. So see which one is larger. This is larger.
0.025.
0.05 is larger than 0.025. Okay, but the rule is if probability value is less than alpha, then we would reject. So in this case, we would remain unable to reject. Don't reject H naught. Don't reject H naught. Fine, or accept H naught. Okay, so this is for one tail, but as it is two tail, as it is two tail distribution, so what will you do? You will multiply this probability value, whatever you have obtained over here, with 2. So 2 multiplied by 0.0, sorry, 0, let me write down it again, 0.59. What is the value? 0.0559.
559.
559. Multiply this with 2. See what is the answer.
Point
Point
one
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 one eight.
eight.
Point
118.
1180.
118. 1118, sir.
0.1118.
Yes, sir.
Is it? So this is your probability value when you are taking into your account two tails. Fine. So now what will be the value of alpha? This is your probability value for two tails. And here you write down alpha. Now alpha will be equal to 0.05, whatever there in the question. Okay. So when you will multiply this with 2, you will compare it with 0.05. So now you have to see that which out of these two is larger. 0.05. This is larger. Fine. P value is larger than alpha. So it means that again, don't reject H naught. Same result. Don't reject H naught. Fine. And you may also consider this value. If you see this value, sorry, 0.0559, 0.0559. So 0.0559 will be somewhere, let's say this is 0.025, this area up to this point, from positive infinity up to this point, it is 0.0, it is 0.025. So let's say up to this point it is 0, let's say up to this point it is 0.0559, let's say. So definitely 0.025 is up to this point. So larger area is being covered by this value. So it is this value up to this point. Okay, so as this value is here at this point, it means that it is in the exception region. So probability value is larger than alpha. It means now you are in the exception region. Fine. Now you are in the exception region. So it means that you would remain unable to reject the null hypothesis. So this is all for today, and you are directed to solve the remaining questions and see if there is any issue, any problem in solving any question. We may solve it in the next class, or otherwise we will move to the next topic. So thank you very much for your
Inshallah, sir.
patience. Allah Hafiz.